All right, guys. Assalamu alaikum. Today we are doing um, IGCSE chemistry. All right. It is October, November 2023, paper 2, variant 3. All right. So let's start with the first question. The first question states that a sample of gas occupies 347 centimeter cube at room temperature and pressure. The temperature and pressure are both increased, but the volume occupied by the gas remains 340 centimeter cube. Which row describes what happens to the particle speed and average distance between the particles in the gas when the temperature and pressure are both increased? All right. If the temperature is increased, then particle speed should definitely increase, right? Because change in temperature corresponds to change in kinetic energy. All right. Whenever temperature is increased, particles gain kinetic energy. They're moving faster. Whenever temperature decreases, particles lose kinetic energy. They're moving slower. Okay. And what about pressure? If pressure increases, pressure will increases because of two reasons. One, something is compressed. If something gets compressed, then pressure increases, all right, because force has been applied. Or when the gas particles within the container, they start moving faster because of high temperature, that is also a time when pressure increases. However, if they say that the volume occupied of the gas remains same, meaning the total volume of gas particles remains same, that means each particle will be at the same distance away from one another throughout the experimentation or throughout the procedure. All right. So because the volume has not changed, the distance between particles should not change. All right. So the answer should be C, that the particle speed should increase, but average distance should not. All right. If the volume had changed, then the average distance would be decreased or increased, whatever the scenario is. Which statement about the rate of diffusion of the gas ammonia, carbon monoxide, nitrogen, and oxygen are correct? Nitrogen and carbon monoxide will diffuse at the same rate. Is that so? If they diffuse at the same rate, they would only diffuse at the same rate if they have the same mass. So let's look. N2 has an MR of 14 plus 14, 28, and carbon monoxide CO has a mass of 12 and 16, that is also 28. So this statement is correct. Oxygen will diffuse slowest because it is an element, whereas others are compounds. Well, um, is it true? Is it not true? We are going to have to understand oxygen will diffuse slowest because it is an element. Well, that is not one way. That is not the way of discriminating things. All right. In chemistry, diffusion does not depend upon something being an element or a compound. It depends upon something being heavy or light. All right. So saying this doesn't really make sense. This should not be considered correct. However, this is true that oxygen is diffusing the slowest, but it is not because it is an element. It is because it has the highest mass. All right. Because it has the highest mass. So this statement should not be considered. Ammonia will diffuse fastest. For that, we have to check the mass of ammonia. We already know carbon monoxide is 28. We know nitrogen is 28. And we know oxygen is 32. It is O2. All right. O2. This is CO. This is N2. Right. Now let's check ammonia. Ammonia is NH3. It has a mass of 17. You should remember it. It will make life easy for you. You won't have to count it over there. NH3 is 17. The mass is the least. So that means this statement is also correct. The answer should be 1 and 3. Two statements are correct. Next question. The structure of an atom of element X is shown. Element X has 5 protons and 6 neutrons. What is element X? Well, to know element X, you don't even need to worry about neutrons. Identity of an element is its number of protons. So which element has 5 protons? That is what you have to identify. Okay. So what we need to do is, first of all, if you remember the first 20 elements, you would know that it is boron. All right, boron has 5 elements. But if you do not remember the periodic table's first 20 elements, they you could remember them by practice. But if you don't remember them, then it is very simple. You go to the periodic table and you see who has the atomic number 5. All right. So boron clearly has the atomic number 5. Carbon has the atomic number 6, meaning it has 6 protons. All right. They also give options sodium, which has 11 protons, and sulfur, which has 16 protons. All right. None of them correct. Only boron has 5 protons. No other element can have 5 protons. So that means the answer to this question is boron. All right. Let's go to the next question. Which statement explains why isotopes of an element have the same chemical reactions? Why do isotopes have same chemical reactions or same chemical properties? Because they have different number of neutrons. That is not true. That is because of this they have same mass and same physical properties. They have ions with different number of electrons. That is also not true. They have same number of outer shell electrons. That is why they have same chemical properties. All right. Question number 5 then. Magnesium reacts with oxygen to form magnesium oxide. What happens to magnesium atoms and oxygen atoms during this reaction? Magnesium and oxygen share 2 electrons. Magnesium gains 2 electrons and oxygen loses 2 electrons. Uh, is that true? No. Magnesium is a metal, all right? It does not gain electrons. It should lose electrons. And oxygen is the non-metal. It should gain electron, all right? Uh, Magnesium oxide over here, as they have mentioned, you should already have established that this is an ionic compound. All right, this is what this is an ionic compound. Okay, and magnesium being the metal should produce the cation. Should produce the cation. All right, this should become the anion. The oxygen should become the anion by gaining electrons. All right, now you should also know how many electrons they gain. So over here in option D, the correct option, magnesium loses 2 electrons and oxygen gains 2 electrons. That is true. That is very true. Okay. Now the next question, which row about properties of diamond and silicon 4 oxide is correct? What are the properties of diamond and what are the properties of silicon dioxide? Okay. Conductor of electricity, yes, yes, no, no. Okay. Diamond and silicon dioxide both are poor conductors of electricity, so it's either C or D. Now, type of molecule is, do they have a giant covalent or simple covalent? So they have a giant covalent structure. They both have very high melting boiling points. They're giant covalent compounds. All right. The equation represents the reaction between solid magnesium oxide and dilute hydrochloric acid to form magnesium chloride in water. MgO plus 2HCl gives MgCl2 plus H2O. Which row shows the state symbol for hydrochloric acid, magnesium chloride in water? So the first one HCl, then magnesium chloride, and then H2O water. All right. Beta, HCl is an acid. It should always be aqueous. It should always be aqueous. MgCl2 because it is soluble in water, it should also be aqueous. Water because it is water, it should be liquid. So aqueous, aqueous, liquid. That is A. Okay. Next question, question number 8. Which substance is a mixture? Air. Yes, it is. Okay, graphite is pure carbon, it is an element. Oxygen is pure oxygen, it is an element. Water H2O is a compound, pure. All right, air is a mixture of gases. Next question, the number of moles of atoms X, Y, and Z in a compound are shown. Atom X, Y, Z 0.6, 1.2, 0.3. What is the formula of the compound? All right, this is the kind of question which requires empirical formula calculation. Now, in empirical formula, you are usually given percentages, right? If you guys remember, you are given percentages. All right. Now here's the thing. Over here, you're not given percentages, but if you remember, whatever percentages you were given, what would you divide them by? You would divide them by their atomic masses, right? You would divide the percentages by their atomic masses. Why would you divide the percentages by atomic masses? Because that would convert them into moles. That would convert them into moles. All right. Basically, you need to write the empirical formula, you need the ratio of moles of that compound. All right. So over here, they've directly given you the ratio of moles. All you have to do is just put X, Y, and Z. Put 0.6 is to 1.2 is to 0.3, and then you just simplify. All right. You're already at the moles point. If you are given the moles, just simply simplify by dividing with the smallest number. So divide them with the smallest number. All right. So it should become 2 is to 4 is to 1. All right. So it should be X X2Y4Z. X2Y4Z. Where is X2Y4Z? D. All right. So it should be D for doctor. All right. Next question. 1 mole of silver nitrate AgNO3 contains 1.2 into 10 to the power 24 ions. All right. How many ions are there in 0.25 moles of iron 3 oxide Fe2O3? All right. So, beta, a question like this, a question like this requires you to understand that these are ionic compounds. Ionic compounds, we use the word formula unit, and how many ions are there in one formula unit. Then you make the unitary method. All right. So, like for example, AgNO3 is a formula unit. Ions in one formula unit, let's call it Fu, formula unit of AgNO3. All right. Ions in one formula unit of AgNO3. Beta, AgNO3 contains just one ion, Ag plus, and one ion NO3 minus, meaning two. Meaning two. Okay. Similarly, let's change the script and let's write for iron oxide, iron 3 oxide. All right. Ions in one formula unit of Fe2O3. If you see clearly, it contains two Fe plus 3 ions and 3 O minus 2 ions. All right. That is a total of 5 ions. How many ions are there? 5 ions per formula unit. All right. Now, in 0.25 moles of iron trioxide, how many formula units would there be? How many formula units would there be? That is something you have to judge. So, how would you do that? So, to find the number of formula units, you are going to multiply this by the Avogadro number. All right. Number of formula units is equals to Avogadro number Na multiplied by 0.25. All right, this gives us 6.02 into 10 to the power 23 multiplied by 0.25. All right, all I have to do is do 6.02 into 10 to the power 23 multiplied by 0.25 equal to, so I get 1.505 into 10 to the power 23. All right, so in one formula unit Fe2O3, all right, ions in 1.505 into 10 to the power 23 formula units of Fe2O3 is equals to X. So X is equals to, you're gonna cross multiply 1.505 into 10 to the power 23 multiply by 5, and this one is going to be multiplied by X because cross multiply, right? Cross multiply to both sides. Okay. So 1 multiplied by X is just X. All right. So all you have to do is just multiply this value by 5. And what do you get? You get 7.525 into 10 to the power 23. That is what you get. 7.525 into 10 to the power 23. Okay. So the answer is going to be C for cat. That is the total number of ions. Next question. Concentrated aqueous magnesium bromide is electrolyzed using carbon electrodes. Okay. Aqueous magnesium bromide is electrolyzed using carbon electrode. For a question like this in exam, but especially this question that is phrased like this, at the end, underline what electrodes there are. Okay. Sometimes they say copper electrodes and we disregard it because it's starting with C. Okay. We don't really focus on it during the exam. We are going very fast. We don't focus on it, but you have to focus on this word. If it says carbon electrode, that means the electrodes are inert and they will not take part in reaction. But if they were saying that it was copper electrode, then there would be complete difference. Then you would do reactive electrodes. You would talk about reactive electrode. The copper electrodes, if they were copper electrodes, the anode would decompose in the solution. All right, cathode would enlarge in size. That kind of stuff would have happened. But anyways, right now, concentrated aqueous magnesium bromide. All right, concentrated aqueous magnesium bromide has 4 ions as it is aqueous, right? It should have the H plus ion from water, and the other cation that it should have should be magnesium ion Mg plus 2. All right, then it should also have on the anion side, it should have the hydroxide ion OH minus. all right, and it should also have the bromide, right? Which equation represents reactions occurring at each electrode? Well, for cathode, we know that H plus will go and get discharged. All right, for cathode, H plus will go and get discharged. You should know that the negative electrode is the cathode. The negative electrode is the cathode, and the positive electrode is always the anode. The tricky part is the positive electrode. Now, because the question says concentrated and it is bromide, right? Here is a rule. If halides are present in aqueous state, then concentration of solution is determined. All right. If solution is concentrated, if solution is concentrated, then halide discharges. If solution is dilute, then OH minus discharges. All right. These are the rules you have to remember. All right. These are the rules you have to remember, that if solution is dilute, then hydroxide ion discharges. If solution is concentrated, then halide discharges. This is only if there is a chloride, a bromide, or an iodide. All right. Chloride, bromide, iodide. If they are the anions, then if they are in aqueous solutions, then before their electrolysis, we have to judge their concentration. Over here, since the solution is concentrated, bromide will get discharged. All right. Now, the next part of this question involves you understanding what happens at cathode and what happens at anode. At cathode, gain of electron takes place. Electrons are gained, like in option A. All right. And at anode, loss of electron takes place, like in option A. All right. So the correct answer is A for apple. You did not even have to consider all others, because the only correct answer could be A, judging from the cathode only, right? Because look, at cathode, the H positive ions will get discharged and make H2. Only option A had this answer. So over here, you couldn't have confused yourself any other way. All right, next question. Aqueous copper 2 sulfate is electrolyzed using carbon electrodes. Which statement is correct? All right, copper 2 sulfate is electrolyzed using carbon electrodes. Once again, you have to focus on the electrode. The electrode is inert. The next thing, there is a sulfate, a polyatomic ion. Now, whenever there is a polyatomic ion, whenever there is a polyatomic ion, polyatomic, one second, polyatomic anion, right? When there is a polyatomic anion like sulfate, phosphate, PO4 minus 3, or nitrate, NO3 minus 1, etc. Right? These are polyatomic anions. Then hydroxide always discharges, regardless of the concentration. Always discharges at anode and produces O2 gas. All right, this is the concept you have to keep in mind. Okay, so which statement is correct? Bubbles of hydrogen gas are formed at the cathode. That is wrong. Hydrogen gas bubbles are not formed at the anode. They could have been formed at the cathode, but over here we have copper. Copper and hydrogen, who is less reactive? Cu plus 2 and H plus, right? Among them, copper discharges. That is the rule. All right. Bubbles of oxygen gas are formed at the cathode. That is also wrong. Oxygen gas bubbles are formed at the anode. Copper is deposited at the anode. That is also wrong. Copper is not deposited at the anode. The blue color of solution fades. That is correct. Whenever you use aqueous copper 2 sulfate solution, all right, and you use inert electrodes, the Cu2 plus ions from the solution discharge, and because the Cu2 plus ions from the solution discharge, they are the transition metals, they are the ones that were causing or that cause the blue color of solution. If they are getting discharged, then the color of the solution would be fading away. Next question. When water is added to anhydrous iron 3 chloride, FeCl3 hydrated iron 3 chloride, FeCl3.6H2O is formed and energy is given out. FeCl3 plus 6H2O gives FeCl3.6H2O and energy is given out. That is something that I quickly saw, right? Energy is given out. All right, energy is given out means this reaction should be considered exothermic, the forward reaction. All right. Which reaction pathway diagram represents the formation of anhydrous iron 3 chloride in the reverse reaction? Okay, here's a good question. All right. So I'm going to erase this. Instead, I'll do it like this. So the forward reaction has been deemed exothermic from the statement. The forward reaction has been deemed exothermic from the statement. Therefore, the backward reaction should automatically be deemed endothermic. How do I know that? I know that because just over here they have said energy is given out. All right. Energy is given out in the forward direction. All right. If the forward direction is exothermic, then the backward direction should be endothermic. All right. And endothermic diagrams are not C and D. C and D show exothermic diagrams. The diagrams in which reactants are above and products are below, they are exothermic. So automatically C and D are wrong. The answer is either A or B. And if we're talking about the reverse reaction looks like this. In the reverse reaction, the reactant is the FeCl3.6H2O, all right, and the product is FeCl3 plus 6H2O, all right. This is the product, and this is the reactant. This is how it should be. All right. So as you can see in option A, they have shown it wrong. They have shown the reactant on the product side. So the answer is obviously B. Look at this. This is the product and this is the reactant. All right. So these are the tiny things you have to consider. You have to clock them. All right. You have to see them. As soon as I read energy is given out and I saw that there were energy profile diagrams, we had to decipher which side was exothermic, which side was endothermic. All right. Another scenario that could have happened was they could have said, and the surrounding temperature cooled. I mean, because of a chemical reaction, and at the end they said, and the surrounding temperature cooled. So that means whatever reaction they explained was an endothermic reaction. It is causing the surrounding to cool down, right? So these are the things you have to consider. Next, ethene reacts with hydrogen. The equation is shown C2H4 plus H2 gives C2H6. The bond energies are shown. All right. What is the energy change for the reaction? They're asking us for the L delta H. So first of all, bond breaking. All right, this is what you have to calculate. Bond breaking first. All right, C2H4 looks like this: carbon carbon double bond, one hydrogen, two hydrogen, three hydrogen, and four hydrogen, plus hydrogen hydrogen. All right, and it is giving us carbon and six hydrogens around. All right, and only a single bond. So first bond breaking. Bond breaking means everything on the reactant side. So first carbon carbon double bond, just one of them. All right. So it is 1 times carbon carbon double bond is 610. So it should give us 610. All right. 4 times carbon hydrogen bonds. All right. Each bond is worth how much? Each bond is worth carbon hydrogen bond 410. All right. Each bond is worth 410. So this should be 1640, right? Where did my calculator go? Right here. 4 times 410. I do know that it is supposed to be 1640. Yeah, but you have a calculator in exam, use it. Okay. Then carbon carbon double bond, carbon hydrogen, four of them. Then one hydrogen hydrogen bond. All right. One hydrogen hydrogen bond means 1 times 436 should give us 436. So add the three together: 1640 plus 610 plus 436. The total value that we get is 22686. All right, 2686 is the total value we're getting. All right, now the next we want to do is bond forming. All right, next we want to do is bond forming. Bond forming. Now, bond forming would require all the bonds to be formed, meaning one carbon-carbon single bond. One carbon-carbon single bond would mean 1 multiplied by 350. So it should be equal to 350. And then 6 carbon hydrogen bonds, right? Meaning 6 multiplied by 410, right? 410. 6 multiplied by 410. Okay. So 6 times 410, this is equals to 2460. 2460. So the energy released in bond forming is 2460. Now you're going to calculate delta H. Delta H can be calculated as bond breaking minus bond forming. All right. Bond breaking was 2686. 2686 minus bond forming was, oh, we haven't totaled it, have we have not. Okay, so let's total it. So 350 plus 2460 plus 350, it should give us 2810. 2810, so minus 2810. All right, so 2686 minus 2810, it should give us minus 124 kilojoule per mole. Which one of them is the right answer? B for ball. All right, B for ball is minus 124 kilojoule per mole. That is what we have gotten as our final answer. Okay, I'll just highlight it over here. Next question. Statement about 4 different acids are listed. 0.0100 mole per dm cube solution of hydrochloric acid has pH of 2. Okay. Ethanoic acid has pH of 3.4. Hydrobromic acid is a strong acid. Ethanoic acid is slightly stronger acid than trimethyl ethanoic acid. All right, so trimethyl ethanoic acid is weaker than ethanoic acid. What are the pH values of 0.1 molar HBr and trimethyl ethanoic acid? All right, so HBr, because it is a strong acid, it should have pH 2. Okay, and it is ethanoic acid is slightly stronger, meaning 3.4 pH for ethanoic acid, so 3.5 for trimethyl. All right, it can't be lesser pH because ethanoic acid is stronger, so trimethyl should have a pH more than 3.4. Because here's how it is. This is neutral. pH 7 is neutral, right? Is neutral. The further away you go from pH 7, the more acidic you get. More acidic you get, right? The lower the pH below 7, the more acidic it is, meaning pH 1 is even more acidic. Anyways, so HBr being a strong acid is going to have 2. So the answer is either A or B. And now could it be 3.3 or 3.5? If ethanoic acid is at 3.4, if ethanoic acid is at 3.4, and we are saying that ethanoic acid is stronger than trimethyl, so trimethyl should be over here. Let's call it 50, right? Trimethyl should be over here, meaning it can be 3.5, right? So the answer can be B, but the answer cannot be A. Okay, it can't be 3.3. Question number 16 then. Anhydrous cobalt 2 chloride is blue and turns pink when water is added. How is this reaction reversed? So here's the thing, cobalt chloride becomes pink when it attracts water. All right, we can make it blue again by removing that water of crystallization. And how do we remove water of crystallization? By heating. All right, simply heating causes removal of water of crystallization. Next question. The reaction between hydrogen and nitrogen is reversible. All right, forward reaction is exothermic. Which change to the conditions would increase yield of ammonia? All right, so forward reaction is exo. All right, backward reaction is endo. All right, okay. um everything we know basically about the Haber process though. Like when we increase the temperature, the yield decreases, right? Reaction becomes faster, but yield decreases. But if we decrease the temperature, then yield increases. All right. So increasing temperature is wrong. Adding a catalyst is wrong. Adding catalyst does not change yield. Increase the pressure. If we increase the pressure, it goes to forward direction because forward direction has lesser moles. All right. So I'll do this and I'll say as forward direction has less moles of gas. Direction has less moles of gas. This was a textbook question, meaning what we have studied in classes exactly came. All right, you could have remembered this from your classes. Ethanol can be turned into ethanoic acid by passing it over hot copper to oxide CH3CH2OH, that is ethanoic acid, and copper oxide is reacted. It still makes ethanoic acid. Oh, sorry, this was ethanol. It has been turned into ethanoic acid by reacting with water and copper. What is the type of reaction? Okay, well, I know what type of reaction this is. You guys should also know. We have studied that alcohols can be converted into carboxylic acid. Okay, alcohols can be converted into carboxylic acid. How? We have studied that they can be oxidized using an oxidizing agent or they can be oxidized using bacteria, right? So I'll write it over here. Alcohols can undergo oxidation to form carboxylic acid. Okay, alcohols can undergo oxidation to form carboxylic acid. That is up. Now, what is this type of reaction? Because because oxidation has taken place, that means reduction should also take place because in every chemical reaction oxidation and reduction occur simultaneously. So if alcohol is being oxidized, something must be getting reduced. And as we can see, copper is losing an oxygen, it is getting reduced. Regardless of that, this is a redox reaction. No matter how you look at it, alcohols, they form carboxylic acid by oxidation. Full stop. That is it. Okay, you can remember it, or you could have used your intuition. Like it had one oxygen, now it gained one more oxygen. This is oxidized. It had one oxygen, now it has no oxygen. This is reduced. Next, when heated strongly, silicon 4 oxide reacts with carbon. All right. Okay, and it forms silicon and carbon monoxide. Which term describes what happens to silicon 4 oxide? What has happened to silicon 4 oxide? And as it has lost oxygens, it has lost oxygens. All right. So it has been reduced, lost oxygens. All right, it lost oxygen. Anything which loses oxygen is deemed reduced. All right, usually. Next question then. Um, which statement about aqueous weak acid is correct? Weak acids are always dilute. Well, no. Always dilute aqueous solution. They can be concentrated. Weak as acids dissociate fully. That is also wrong. Okay. When a weak acid is added to blue litmus paper, it stays blue. Nine. Weak acid also makes the litmus paper red. When a weak acid is added to solid magnesium, effervescence is seen. Yes, weak acid, strong acid, magnesium is a reactive metal. It will cause slight production of hydrogen gas. All right, so my answer is inclined towards D. D should be the right answer. All right, all the other options were wrong. Effervescence, and whose effervescence? Effervescence of hydrogen. All right. Next, which oxides are basic? Calcium oxide, yes. Sodium oxide, yes. Iron 3 oxide, yes. They are all considered basic oxides because they all react with acids to form salt and water. All right, they all react with acids to form salt and water. So the answer is A. All right, they all react with acids to form salt and water. Okay. Next question. Zinc oxide is an amphoteric oxide. Zinc oxide is added to excess dilute hydrochloric acid. Zinc oxide is added to excess aqueous sodium hydroxide. Which row describes the observation made in these reactions? Which row describes the observations made in these reactions? Okay. When it reacts with excess dilute hydrochloric acid, colorless solution forms fizzing. All right, when zinc oxide is added, yeah, I think a colorless solution would form. Would fizzing take place? No, fizzing basically means gas is being produced, but amphoteric oxides, when they react with acids, they produce salt and water. When they react with bases, they produce salt and water. So, regardless of uh, matlab having an acid or a base, they won't produce gas, right? So fizzing should not take place, right? Fizzing, it shouldn't really take place. Okay, so when zinc oxide reacts with hydrochloric acid, it should produce zinc chloride, ZnCl2. That is a colorless solution, right? And it should also produce H2O, should also produce water. So colorless solution should form. The answer should be A or B. Excess aqueous sodium hydroxide. We have discussed that it produces sodium zincate, NaZn, and it produces NaZnO2, right? Is it Na2ZnO2, right? Sodium zincate. That is the formula. And along with that, it also produces water, right? It also produces water, right? NaZnO2 plus H2. That is how it should produce when it is reacting with alkali. So in both situations, soluble salts are forming. I know this salt is soluble. Why? Because it contains sodium. Sodium causes any salt in this world to become soluble. All right, so the answer should be A. Next question. Which row shows properties of an element that is in the same group of periodic table as lithium? All right. So we have to talk about their property. Are they good electrical conductors? The answer is yes. They conduct electricity because they are metals. All right. So the answer should be A or B. Next, what about their density? Do they have high density? No, they have low densities. They even tend to float on water. So the answer is A. Next question. The elements in group 7 include chlorine, bromine, and iodine. All right. Which statements are correct? Iodine is more dense than chlorine. That is true. Density of halogens decreases down the group. Iodine displaces chlorine. Wrong. We don't even have to read further. Chlorine displaces iodine because reactivity decreases down the group. All right. Next, bromine is diatomic nonmetal. Bromine is a diatomic nonmetal. Yes, that statement is correct. Yeah, it is a diatomic and it is a nonmetal. Chlorine gas is darker in color than bromine vapor. No, wrong. Uh, the color becomes darker down the group. That is also a trend that we have studied. All right, these are all trends that we have studied. So the answer is 1 and 3 only. Next, cobalt is a transition element. What is the property of cobalt? All right, so what is the property of cobalt? Because it is a transition element, it should form colored compounds. Yes, that is true. It is poor electrical conductor. No, because it is a transition element, that means it is a transition metal, because all transition elements are metals and they have characteristic metallic properties, like good conductor of electricity, like high density, like high melting boiling point, like high malleability, right? Those things as well. So the answer is clearly A. Next question, 26. Which metal has variable oxidation numbers? Transition, right? The metals who have variable oxidation numbers, transition metals. All right. Transition metals. Out of these, only copper is the transition metal. All right. Next question. Which statement about alloys is correct? Alloys are pure elements. They are pure metal elements. Well, no, they are actually mixture. Okay. At least two or more metals react together. No, they do not react. Okay. So this is wrong. This seems wrong. All right. Alloys can be harder and stronger than pure metals. That is something which is true. Steel is not an alloy. That is wrong. Okay. So the answer is C. Next question, a metal M is between sodium and magnesium in the reactivity series. Which reaction occurs with M and its oxide? All right, metal M is between sodium and magnesium in the reactivity series. Okay, between sodium and magnesium. So for that, we have to write the reactivity series: potassium, sodium, lithium, calcium, magnesium, then aluminium. So according to our reactivity series, we only have lithium and calcium. M reacts with this steam. Does M react with this steam? The answer is yes, because all these guys react with the steam down till calcium, right? So lithium and calcium both have the ability to react with steam. The answer is either C or D. Now, M can be extracted by heating it oxides with carbon. No, none of these guys can. All these guys are extracted by electrolysis. So the answer is yes and no. C for cat. Okay. Next question then. The diagram
Wait,
show,
sir, can you repeat the
yes.
electrolysis part?
Better look from the reactivity series. What do you know? You should know the whole reactivity series: potassium, sodium, lithium, calcium, magnesium, aluminium, and then in the reactivity series we put a carbon, and then we put zinc, and then we put iron, and then we put tin, and then we put which one was it, lead, Tb, and then we used to put a hydrogen over here, and after hydrogen we used to put copper, silver, gold, and platinum. Now there was a reason why carbon was placed and hydrogen was placed. Our question over here asks us the reason for carbon. Basically, the theory, do we understand carbon or not? All right. For that, we have to understand that these guys, they cannot be extracted in the blast furnace. Why? Because they're more reactive than carbon. This is a statement that is mentioned in the chapter called metals. All right. You should also refer to it. That chapter, it's called metals. Try referring to it. All right. Over here, a more clear understanding is written over there. However, I'll just give it to you in simpler terms. Because carbon is less reactive, it cannot snatch away the oxygen from any of these guys, right? A less reactive can't snatch something from a more reactive in an easy term, right? So these guys cannot be reduced in the blast furnace, because in the blast furnace, carbon basically takes away oxygens of these guys because they are lesser reactive. But these guys can't, that can't happen. So what did we used to do? And as an example, we saw the extraction of aluminum from its ore bauxite. Did we do it in the blast furnace? No, we used electrolysis, right? We use electrolysis, molten aluminum oxide and cryolite mixture, right? We use that kind of thing. So why do we do electrolysis? Because these are more reactive, right? Extracted by electrolysis, by electrolysis. And these guys, all right, these guys, they are extracted by reduction in blast furnace. That is the concept we develop. All right. Now, some of you might even argue with me, sir, these guys are so unreactive. Do they even have to be extracted? No, no, they have to be cleaned up. Okay, gold and platinum. These guys, they're just mined from underground. They usually are found in their elemental form. They have a lot of mud on them, so we just clean them up. All right, we melt them and we clean them up, and then we collect them. Okay, so these guys don't even need extraction. I've just written it like this. Because it doesn't really matter. The main point has been delivered. Next question. The diagram shows experiments to investigate rusting of iron nails. All right. So iron nail, tap water, salt water, boiled water, layer of oil. In which test tube do the nails rust? Here's the situation. For a nail to rust, you need air and moisture both. For a nail to rust, you need air and moisture both. When I say air, you need oxygen. All right. You need oxygen. Okay. If you put a layer of oil, if you put a layer of oil, then air can't penetrate through and come into this water. All right. So this iron nail should technically be safe. It should technically be safe. All right. Secondly, because the water has been boiled, do you know what boiling does to water? It basically removes all gases from the water. All gases that are mixed from the water, they have been removed. Basically, boiled water is water which has been distilled, which has been distilled, right? So it's just basically distilled water. When there is distilled water, it contains no impurities, contains no gases in it. All right, it is not carbonated. Any other sort of things, they are not there. Therefore, this iron nail should not rust. That is what they're trying to ask us. Tap water, Well, it contains water and then there is open space, air will come in. Salt water is terrible, right? Salt water increases the rate of rusting. Salt water causes rusting faster than tap water. And the cleaner the water, the more distilled the water, the better. Okay. 1 and 2. B for ball. Next question. Which equation represents a reaction that takes place when iron is extracted from its ore in the blast furnace? Reaction that takes place when iron is extracted from its ore in the blast furnace. Calcium oxide reacting with silicon dioxide produces calcium silicate. That is a reaction that takes place in the blast furnace when we are extracting iron. But let's look at the others as well. Maybe they're asking specifically a reaction related with iron. Okay, CO becoming C plus CO2, that is wrong. CaO plus CO2 becoming CaCO3, that is also wrong. They are reversed, right? The reverse of these reactions are taking place. Fe plus 3CO2 gives Fe2CO3. What? That is absolutely wrong. Okay, so answer was A. Some uses of water are listing drinking, chemical reactions, swimming pool, washing. For which uses is it necessary to chlorinate the water? So we need to chlorinate water for drinking. We need to chlorinate water for swimming pools. All right. 1 and 3 are the clear choice. All right. In both cases, water is coming in contact with our eyes, with our orifice. Orifice means our holes, ears, nose, mouth. All right. These are all our orifice. Water when goes through it, if it contains germs, it's going to get us infected, it's going to be septic for us. All right. So that is the reason why 1 and 3 should be the right answer. All right. Drinking and swimming both introduce water to places that are beyond our skin. All right. This is not biology, but if you understand, skin is the first barrier. If anything crosses skin, then it needs to be very well sterilized, because skin protects us. After that, there is very limited protection. All right. Oxides of nitrogen are formed in car engines and are a source of air pollution. The decrease To decrease this pollution, catalytic converters are fitted to car exhausts. What happens to oxides of nitrogen in the catalytic converter? Their oxygen has gets removed. A very famous reaction of oxides of nitrogen is this: NO plus CO, carbon monoxide and nitrogen monoxide, produces N2 and carbon dioxide. To balance the equation, we put a 2 here, and 2 here. All right. This is how we balance this equation. All right. So as you can see, the oxygen has been removed, nitrogen has been reduced, carbon monoxide gets oxidized. That is how catalytic converters are working. All right. Let me just elaborate that by doing this. All right. This has been reduced. All right. And this has been oxidized. Next question. Which pair of compounds are structural isomers of each other? CH3, CH2, CH3, and CH3, CH2, CH2, CH3. Are they structural isomers? Of course not. They don't have the right formula. For two things to be structural isomers, their formulas should be same and their structures should
Sir,
be different. Yes.
you didn't circle the answer for the previous question.
Oh, sorry. What happens to oxides of nitrogen? All right. So nitrogen is reduced. Reduction takes place. All right. Next question. Which pair of compounds are structural isomers of each other? CH3, CH2, CH3, and C. So their formulas are wrong. This guy has the formula C3H8, and this guy, as you can count, has the formula C4H10. So they have the wrong formula. Structural isomers should have the same formula but different structures. Structural isomers have same molecular formula MF but different structures. All right. So let's look at this one then. CH2 double bond CH, CH3, and CH3 CH double bond CH2. Do they have the right same formula? The answer is yes. C3H6, C3H6. But are they structural isomers? The answer is no. What? Sir, why are they not structural isomers? Because they are the same thing. All right. Structural isomers, the best way to determine their structural isomers is to determine that they have different names. These guys have the same name. All right. It's a 3-carbon alkene. A 3-carbon alkene cannot have structural isomerism. All right, that is something we studied as a concept, that structural isomerism in hydrocarbons. Structural isomerism in hydrocarbons starts from carbon number 4, meaning 4 or more. If there are 4 or more carbons in a hydrocarbon, meaning a compound containing carbon and hydrogen only, then there is structural isomerism. All right, you have to remember that. That will help you answer questions quickly. Okay. Basically, these are the exact same things. Structural isomers should have different structures. These have the same exact structure. It's basically rotated. All right. So CH2 is on the first, and then CH, and then CH3 right here. CH2, CH, and CH3. The name is gonna be the same. CH2 OH CH2 CH3. This is propanol, right? And it has the formula C3H7OH, right? And this guy CH3 CH2 CH2OH. This is also propanol. C3H7OH. These two have the same molecular formula. Are they structural isomer? The answer is yes. The answer is C. All right. These are not hydrocarbons now. They can have 3 carbons and still have structural isomerism. How? By the position of their functional group. The position of their functional group. All right. So the two positions are this CH2. 1 second. Oh, oh, they are not. They are not. They are not structural isomers. We can't say they are structural isomers because look, the OH is on the first carbon regardless of which side, right? The OH is still on the first carbon. The OH is still on the first carbon. I thought the OH was on the middle carbon. The OH is not on the middle carbon, all right? In this one, the OH is still on the first carbon. In this side is the OH also on the first carbon. So this is also wrong. So last one, CH3, CH2, CH2, COOH. This is carboxylic acid. All right. It's called butanoic acid. C3H7 COOH. All right. And then this guy, or because we are writing for isomerism, so we'll just write C4H8O2. That is what its formula is. CH3 COOCH2 CH3. This is ethyl ethanoate and ester. C4H8O2. All right, C4H8O2. And now if you look closely, it is the type of structural isomer that we studied last, right? There were 3 types of structural isomer: chain isomerism, positional isomerism, and this is functional group isomerism, right? Different functional group, but same formula. Functional group isomerism. All right, so the answer is D for doctor. Next question. Methane reacts with chlorine in sunlight. CH4 plus Cl2 gives CH3Cl plus HCl. Which statement about this reactions are correct? So which of the statements is correct? CH4 reacting with Cl2 gives CH3Cl plus HCl. This is what we call a substitution reaction, which requires UV light, right? So let's see, it is a substitution reaction. Yes. All right. It is an addition reaction. No. It is a photochemical reaction. Yes. It is a photochemical reaction. Okay. It requires light. It is a catalyzed by nickel. No. There is no catalyst required. So 1 and 3 should be the right answer. Okay. Why is it a photochemical reaction? I'll write over here. Requires UV light. Requires UV light. Propene reacts with bromine to give one product only. What is the formula of the product? Propene, which is CH3, CH double bond, CH2, right? When it reacts with Br, right? Let's write Br like this because Br is Br dash Br, bromine bonded to bromine. What happens is that this bond breaks. It becomes a single bond. It becomes a single bond, and I elaborate it like over here. I'll elaborate for you guys. So okay, so one of the bond will remain, the other bond is weak. It is going to break in presence of something like bromine. All right. All right, when it breaks, all right, 2 bonds are going to emerge. All right, one on each of them, right? So let's show it on the other side. Second, let me make it non-dotted. Let's show it on the other side. CH3 CH, single bond CH2, and now the 2 bonds will contain bromines, right? Like that. Okay. This bromine bond also breaks, right? These are the two bonds that break. Okay. And bromines join on each carbon. So this bromine joins with this one, and this bromine joins on this carbon. All right. So the formula should become CH3, CHBr, CH2Br. All right, like that. So CH3, CHBr, CH2Br right here. See, okay. They don't have the bracket. I've put the bracket, but they haven't put the bracket. The answer, however, is still C. Okay. Question number 36 then. Ethanol can be manufactured by fermentation or by catalytic addition of steam to ethene. Which statements describe an advantage of manufacturing ethanol by fermentation? All right, labor cost is very low. The yield of ethanol is low. That can't be an advantage. All right. The method uses batch process. That could be an advantage. A lot of ethanol is manufactured at the end, and a lot of it is collected and supplied. All right. The process takes place at lower temperature. Yes. The ethanol is made from a renewable source. Yes. All right. So two, three, four, they're all advantages. Now we have to choose which ones are the best advantages, right? Which ones are the best advantages. Now, a thing about batch process, there is a continuous argument that is batch process good or is continuous process good. Well, in industries there are batch processes as well as there are continuous processes. Like for example, the making of cold drinks usually takes place in continuous processes. We have seen in movies and stuff and in maybe ads how bottles are just on a conveyor belt. They're moving, they're filling and capping. Each one of them is being capped uh, simultaneously, right? One after the other. That is a continuous process. Every second a bottle is being made. All right. But for example, making that cold drink, making that liquid is a batch process itself. Like you make 1 ton of that liquid at a time. All right. A lot of effort goes into it and then you make it at a time. Okay. So that is a batch process. So some places batch process is good, some places continuous process is good. Okay. So we can't deem it 100% advantage. However, 3 and 4 are stronger advantages. All right. 3 and 4 are stronger advantages. So I'll say I'll do like this curly arrow and a tick, meaning sometimes advantage, sometimes not advantage. But 3 and 4 always advantage. The process takes place at lower temperature. The ethanol is made from renewable source. All right. So 3 and 4 is very good answer. Question number 37 then. A compound with the formula CH3COOC2H5 is formed from ethanol in two separate reactions. This is ethyl ethanoate. Ethanol reacts to form ethanoic acid. Ethanoic acid and ethanol react to form CH3COO. Which row describes reaction 1 and reaction 2? Reaction 1 is oxidation, right? Making alcohol from carboxylic acid. They have already asked this question in this paper. They have repeated the same concept again. Ethanoic acid and ethanol react together to form. This is esterification. Esterification is also called condensation reaction. All right. Sometimes this reaction might be regarded as condensation. If the options say esterification, then good. If the options don't say esterification, then if they say condensation, the answer is still you choose condensation. All right. So esterification and oxidation. So the answer is A. Reaction 1 is oxidation. Reaction 2 is ester formation. All right. Next, the flow diagram shows polyethylene may be made from petroleum. Petroleum, it becomes fuel oil. All right, from petroleum, we obtain fuel oil by fractional distillation. Then from fuel oil, we make ethane by cracking, right? The petroleum gives us alkanes usually, all right? We make alkenes by cracking, all right? Then from ethene, we do addition polymerization, all right? So this should be fractional distillation, FD. This should be cracking, all right? And then this should be polymerization or addition polymerization, all right? So polymerization. I can already see that this should be C. Fractional distillation, cracking, and polymerization. Next, RF values are used to identify substances using paper chromatography. Which statements about RF values are correct? RF values are always less than 1. Yes, that is true. Because solvent always travels a further distance, meaning denominator is a greater value than numerator. All right. Denominator should always be more than the numerator. So 1 is 100% correct. RF value is equal to distance traveled by solvent divided by distance traveled by unknown substance. Wrong. Distance traveled by unknown substance divided by distance traveled by solvent. The other way around. All right. The higher the RF value, the further the unknown substance travels. That is true. A higher RF value means that the substance is traveling further away, is more mobile in that solvent. All right. Next, RF value are not affected by solubility. No, that is wrong. Solubility is everything. Matlab, RF value is completely dependent upon solubility. So B is the correct answer. Question number 40 then. The results of some tests on aqueous solutions of substance X are listed. A cream precipitate is produced when adding aqueous silver nitrate. All right. Cream precipitate is produced, meaning this should have a bromide ion. All right. Adding aqueous sodium hydroxide produces green precipitate which dissolves in excess alkali. A green precipitate which dissolves in excess alkali. Now, here's the problem. The green precipitate is produced by Cr3 plus as well, and it is also produced by Fe2 plus. All right. Now, for this question, you have to remember whether that precipitate dissolves in excess alkali or not in presence of NaOH. All right. For this question specifically, you have to remember. All right. And now, for those who would remember, would say that, sir, iron used to be insoluble, chromium used to be soluble. All right. So over here, because green precipitate, this means it could either be chromium Cr plus 3 or it could either be Fe plus 2. All right. And now, which dissolves in excess alkali, this was already confirmation of Cr plus 3. All right. Now, next, adding aqueous ammonia produces a green precipitate which is insoluble in excess. Which is insoluble in excess ammonia. So the green precipitate is insoluble in ammonia. That confirms that it is Cr plus 3. All right, that confirms that it is Cr plus 3. Okay, because green precipitate is produced in both Fe plus 2 and Cr plus 3. So it should be iron 3 bromide. A should be the correct answer. Iron, oh, sorry, chromium 3 bromide. A should be the correct answer. Okay, because this is confirmed chromium. All right, with that, this past paper has been completed. I hope you guys have no questions.